In this lecture, I want to talk about another application of radioisotopes, medical applications. We use them both diagnostically to determine if there's a problem with an organ and therapeutically to treat a disease state. So, some of the diagnostic tools that we have is using radioisotopes as radio tracers. And so that's useful when there's a organ that'll absorb one type of element more than other organs. And we can take the radioactive isotope of that element and ingest it into the body. And as it goes into the body, it'll accumulate in that organ. And then we can visualize the different and detect the particles coming off of it and see it. And see if it can give us a lot of information about if it's functioning correctly or if it's not taking up that element and it isn't functioning correctly. We also use them in PET scans, which are positron emission tomography. We use actually fluorine 18 in this, and it's used to observe brain function. And so it's using positrons to like actually image, which is interesting. Therapeutically, we use this in cancer treatments primarily. So there's some different types of that. There's brachytherapy, teletherapy, and radiopharmaceutical therapy. So brachytherapy is going to be the insertion of or like placing a radioactive isotope within the tissue. And so there's a number of examples of these, everything from just like placing in a radioactive rod or wire into, let's say, breast tissue for treating breast cancer, leaving it in for a period of time and then removing it. All the way to types of brachytherapy where you take little seed crystal, like little seeds of a radioisotope that has maybe a shorter half-life and actually implant them into the organ that has the cancerous cells. And so this is sometimes done with um, prostate cancer, and then you insert these seeds and they will give off radioactive particles into the localized area until it decays to a certain amount of time. So the person then who's undergoing that kind of treatment is actually radioactive for that period of time as it decays. And radiopharmaceutical therapy is like actually ingesting something that'll become systemic and collect hopefully somewhere in the body. And teletherapy is when we're actually, so here's an example, is where we're using gamma rays to target an area. And so one example is with cobalt-60. So cobalt-60 will decay through gamma radioactive decay to nickel-60. It also is going to have a beta particle that is given off through that process. And so it's a beta decay followed by a gamma radiation decay. And so we can use that source of cobalt, which has a really long half-life, like 5 years or more. And you wouldn't want to have that in your body giving off radioactive particles for like the rest of your life. And so instead we target an area and focus those gamma rays at one specific spot. We've got a picture of that right here.